All right, everyone, welcome to our next module in the auto electricity and electronics area that we're going to be discussing. So last week we got into some of the lighting and they actually did a little bit of the lab that was related to this. So this week we're going to try to focus a little bit more now on the lighting system diagnosis and repair strategies for these various systems that are in the vehicle. And the lights have gotten quite complex on vehicles, mostly because it is recognized as a safety device or safety item. So this week we're going to be looking at how to carry out those troubleshooting procedures for most of the common problems. We're going to also talk about some of the proper procedures to remove and replace these light bulbs. Some of them are very sensitive. We also want to summarize, some of the techniques for checking and aiming headlights. And I'm hoping to be able to do this with you in class to take you through a demonstration. We will also try to carry out proper procedures for replacing a turn light switch. And you might have seen last week we had something very similar to what is known as a contact spring or clock spring on some vehicles. We'll also learn about how to test these instruments and warning light sending units. And a lot of this is going to apply to what we've been practicing in our classes with our electrical boards. We'll talk about how to test certain gauges that are available, whether they're an analog or digital design. And then we will also review the proper procedures to remove and replace a dash cluster, which we actually were fortunate enough to get into already. We'll also talk about how to demagnetize a vehicle, and this can be very important for a variety of reasons to not cause damage. So the very first step in the lighting system diagnosis pathway is to determine if we have what the condition is, right? Do we have one bulb out? Do we have all the bulbs out? Do we have a section of the bulbs out? Are the lights flickering? Are the lights dim? Because each one of these conditions takes us in a different pathway. One bulb being out is probably most likely a bulb that simply has blown. If all the bulbs are out, we probably have a circuit failure. Now, when we go to do the headlight service, there are methods of replacing the insert in the headlamp, and we remove from the rear of the housing to do this. We don't want to touch those filaments. That glass is very sensitive and usually under high pressure. Replacing a sealed bulb, though, is a different story. That we have to remove a cover and loosen the screws that hold the trim in to remove the whole physical bulb and then fit a new bulb into this carrier element. These are more popular with older vehicles. Here you can see that cover that goes along the outside and the screws that's usually decorative. And then we have to actually get the tin, I call it tin, that goes around the outside. And we want to be a little bit careful with this, not to try to force it or wiggle it back and forth because they can break and lead to problems. Also, these screws are usually small Phillips, and these screws can actually strip pretty easily. So usually want to get them kind of loosened up with some kind of lubricant or penetrating oil if we can. Here you can see that trim piece pulled out, and then it removes the whole bulb. You can see this bulb's rather large. The nice part about this, back in the day, there was only about two variations of these bulbs that you could get. There was a small one and a large one. And they also made some round bulbs that were like this. So it limited kind of the complexity of the bulbs. Today, the ones with the filaments in the back, there's a huge variety of these bulbs that are out there and options. Now, once we replace those bulbs, we're going to have to talk about aiming the headlights. Now, there are headlight aimers out there that handle the vertical and the horizontal control of these. And we want to check both the high and the low beams when we do this. Some shops will have this physically set up on the floor where they've marked off certain areas. Now, this can be a bit tricky with some cars that have what they call self-leveling headlight assemblies, but those are the exception rather than the rule. Now, if we want to look at the headlamp for switch diagnosis, we want to check this either with a test light or, my recommendation is usually a digital volt ohm meter. We want to check that there's power to the various output wires that should have power according to the wiring schematic. We can also try to power that switch if we're missing power, right? Which actually we probably should be going back and making sure that fuse is okay? And then the relays in between the switch and the bulbs. Again, we want to look at the service manuals to get a lay of the land, which is why we've been looking at schematics. Here, you can see a typical switch that may be in a vehicle. There's usually some kind of retainer that holds it in place, and the actual switch, the physical switch, is usually behind the dash. So what you're pulling on is activating it behind the dash. Usually you get to this by getting underneath the driver's side foot area and working up behind it. Now it can be tight, it can be difficult to get on some of these, but again, you get nimble over time and getting access. All right, so we have fog lamps as well, and these bulbs are very similar to headlight bulbs in many cases. The bulbs get burned out. They can have switch problems, wiring problems. We're going to still use our basic testing methods. And just to make sure that you understand, a lot of these fog lamp bulbs that set close to the road surface typically are knocked out by some kind of like rock flying up in the air, and it usually breaks the lens, causes water intrusion. So keep an eye out for this as well. Now, let's talk about some of the testing procedures that we're going to see. We got bulbs and sockets that need to be serviced. So when we have to change one of these, we want to remove the bulb and we want to inspect it for a burned element. Usually you'll see some kind of broken piece of the filament. More so, we want to take a look at the contacts where it pushes into the socket and see if we're seeing signs of maybe burning or heat that's happened, or sometimes these actual index lugs will break. What's most important is that you use a voltmeter to check the socket for power, right? The bulb does not work. You want to check that socket. And then if you don't have power there with your voltmeter, you'd want to trace that circuit back through the wiring to see where the power is supposed to be fed from. They also make some very nice brushes. I actually have used some of the plumber brushes that are out there for cleaning copper pipe that can clean these sockets out, especially as they get older, they start to build up with carbon. Now, removing and installing the bulbs can vary depending on the setup. So some of them have what they call a lug type that just kind of pushes in and out of the socket, straight in and out, and then actually locks into place. You'll find these usually on the marker lights. Then there's like the prong type that you see here. Those go in and usually push down on some kind of spring-loaded backing and then lock into a groove. Both of these bulbs, I warn you to be careful. They can get quite hot. Now, we also have what they call a wedge-based and a double-end bulbs. The wedge-based works very similar to the push-pull style. They wedge in there. The contacts are right there on the bulb, folded over, that go to the filament. These, you got to be careful about corrosion. And the same thing with the double-edged bulb. It's funny, these double-edged bulbs probably resemble something very similar to some fuses you may have seen in the past. But these indeed light. They used to use these on dome lights in cars, and they're kind of wedged between two spring-loaded elements. Then we have the flasher service. Now, on the flasher service, there's usually some kind of flasher relay that's involved. And if you suspect a flasher, if there's any of the turn signals that fail to work, right? Both of them aren't working, then we want to look at this guy. You can check the service manual again for the location. Typically on these flashers, though, once you locate them, replacement of them is fairly easy. I used to keep a couple extra of these in my toolbox just as test units to use on vehicles. There's also the turn signal switch that sometimes will need service. Often these go bad. Maybe it won't operate one direction or the other. Many of these have a bunch of combination switches, so the wiper blade might be included with the turn signals. If any one of those switches fail, you end up having to replace the whole unit. So again, on these, as we started to look at earlier this week, make sure that you read the service information, because there's usually a certain position the steering wheel is supposed to be in before you take that out. Now, on the brake light, if we have to replace this guy, most are mounted directly on the brake pedal itself. And there's usually some kind of mechanical operation of this. Some are mounted on the master cylinders or a brake line, and they use hydraulic pressure. They're a little pressure sensor. But the majority of them are actually switches on the pedal. This, you can typically use a test light, but again, you know my favorites use that digital voltometer, and we can see if that switch is going open or closed. Now, servicing the interior light switches on the vehicle, you'll find these in many locations. Sometimes they're actually built into the door latches themselves, or sometimes just into the B pillar that you're seeing here. Those interior switches are designed so that when you open the door, it'll actually trigger or send a signal that says, hey, turn on the interior lights when you go to get in the car. Then when you shut the door, it collapses that spring-loaded switch and causes the lights to go out. Now, we can also have the emergency brake switch. And this is when you pull up on it, usually get that indicator on the dash that's telling you that it's applied. That doesn't mean mechanically it's applied. It just means that the switch has been triggered. And again, we can use that digital volt ohm meter to go in there and check and see, hey, when I open and close this, maybe I want to check for voltage. We can do that voltage drop testing that we learned. We could also do maybe an ohms test to see it's going open and closed. Now, instrumentation service, we have been over this past week. We want to check that instrument for problems. Some of the conventional gauges that we see are using ground wires to the sending units, right, to trigger these. The gauge should read maximum or minimum, so you can easily work around this by simply grounding that switch. Also on here, you also have a gauge tester, or sometimes called a decade box, that will simulate resistance. Now, here's that decade box. This one's special for this application here, and indicates whether it should read empty, half, or full tank if we were checking the fuel level gauge. Now, keep in mind, these decade boxes are out there. They're nice. They're little packages of resistance, and most of the service information will provide you some kind of expected resistance at empty, half, and full levels that you can use. So those decade boxes are really nice to have. You can simulate lots of sensors to test these types of gauges. If we need to remove a gauge from the cluster, we're going to have to take out that trim work. We want to be real careful in this area to get out the plastic that usually surrounds it to get access to that instrument cluster. And then the instrument cluster itself will usually have either some securing bolts, or it might be wedged in. Be very careful though for vehicles that use a mechanical speedometer cable. This usually is a hard cable, and we need to reach back and get that disconnected. Now, when we take that dash out, some of these have a removable odometer memory chip. This has pretty much been done away with, but older odometers used to have this. If we were going to replace one, we could switch that odometer memory chip to the new unit. Now, for obvious reasons, this has gone away. People cheating the system and rolling back odometers, so you don't see this much. But you handle this the same as a computer prom chip. You don't touch it with your fingers, and you got to be very careful not to bend the pins. Now, the auto-dimming mirrors that are on many of these vehicles, just some common sense here can help out. You can shine a shop light on the photoelectric sensor, and the mirror should become shaded, right? Or you could tape over the photoelectric sensor, and the mirror should become clear. You could also shift into reverse, and that mirror should be clear. These are usually default functions of those dimming switches. You just have to know where that photoelectric sensor is located on the car. Now, testing those entry lights, one thing I want to mention here is the ECU make control entry lights. Often we are able to control this inside the instrument cluster by toggling switches and saying how much time we want those to stay on or go off. Also what they call walkway lights when we go to get out of the car. Refer to the wiring diagram, take a look and see if you see any of those types of controls involved. And, you can also, you want to read about the operation of how a specific unit works. Now, lastly, just want to talk about demagnetizing of a vehicle. This usually will happen if vehicles have been exposed to certain elements. This is real simple. You basically just take a magnet and you use it in a microfiber towel. You can kind of work this down over the vehicle, and you want to have the north and south poles of that magnet facing that, and that will help demagnetize. You actually do this with a screwdriver. If you use the flat surface and pull it down on one side, it'll magnetize the screwdriver, and if you use the north and south poles, it will demagnetize your screwdriver. So that's a handy trick to know in the future. All right, so if you guys have any questions about any of these items, please let me know. There's so many switches that are out there that are affected by various types of lights and LEDs. We're going to try to practice some of these in class and continue exposing you to how to test those lights. I believe that many of you probably already have this skill set just by practicing on those electric boards. All right, but please, if there's something that you're missing, don't hesitate to reach out, and I'll see you in class this week. Thanks, everyone.